6.5, the triangle midsegment theorem. So first of all, the definition of a midsegment. A midsegment of a triangle is a segment that connects the midpoints of two sides of the triangle. Every triangle has 3 midsegments, which form the midsegment triangle. So if we take a look at our image over here, a midsegment connects the midpoints. So if I look at the side AB, and then I look at M is the midpoint of AB, so that I know AM and MB are the same length. It like cuts it in half. Then if I do the same thing on the other side of the triangle, and I put the point that cuts it in half, and then I connect those 2 points, then MP is a midsegment of the triangle. Now you can do that on all the other sides. You know, if I drew that one, which is cuts this side in half and connected them, then I would have this smaller triangle inside, which is called the midsegment triangle. Now, the triangle midsegment theorem says that the segment connecting the midpoints of 2 sides of a triangle is parallel to the third side and is half as long as that side. So what's happening here is if I have DE, which is a midsegment because these are congruent and those are congruent, so that's a midpoint and that's a midpoint, then I know that DE is parallel to the third side, which is AC. That's the first part of the midsegment theorem. And then the second part is going to tell me that DE is 1/2 the distance of AC. Meaning, if I were to tell you that AC were 10, then what would DE be? Well, DE would be 5 because it's half. Now, before I actually let you use the midsegment theorem, we're going to prove the midsegment theorem. Okay, so we are given that in our diagram over here, DE is a midsegment of triangle OBC. So we know that DE is a midsegment of OBC, of the bigger triangle. So we have to prove the midsegment theorem, which says then, okay, well then DE is parallel to OC. That was the first part, that these are parallel. And then we also have to prove that it is 1/2 of this side. Now, in order to do this, we are actually not going to do a 2-column proof. We're going to do a coordinate proof, which also looks a little bit like a paragraph proof, but it's just a coordinate proof. And the way these work is we're just going to step it out. And there's going to be 3 steps. So, step 1, we're going to find the coordinates of D and E. Now, in order to do that, we know that DE is a midsegment. Well, if it's a midsegment, that means that this is a midpoint. Well, if it's a midpoint and I want to find the midpoint, okay, we'll take some notes here. Midpoint is where you take the x1 plus the x2 and cut it in half, and then you take the y1 plus the y2 and you cut it in half. That finds your midpoint. So if I'm trying to find D over here, which is the midpoint of OB, I'm going to take my x coordinates, which are 0 and 2q. So we're trying to find D right now. So I'm going to say D. And I'm going to take 0 plus 2q. And I'm going to cut it in half. And then for my y's, I'm going to take 0 plus 2r. And I'm going to cut that in half. Now, that's going to give me 2q over 2 and 2r over 2, which is ultimately going to give me q r. So I know the coordinates of D are q r. So we went over q and we went up r. Now we have to do the same thing for E. And E is the midpoint of BC. So now if we do E, I'm going to take the x's. So I've got a 2q and a 2p. So 2q plus 2p over 2. Now I'm going to take the y's. I have a 2r and a 0. So 2r plus 0 over 2. Then we're going to simplify a little bit. So 2q plus 2p, I really can't do much there because they're different, but I can divide everybody by 2, which is going to get me q plus p. Then 2r plus 0 is 2r. We're going to divide that by 2, so that's going to get us r. So I know the coordinates of E over here are q plus p, comma, r. And notice that if this is from 0 to 0, and this is from r to r, these are kind of at the same height here, which are r. But anyways, that's step 1. We found the coordinates. Now, step 2. Step 2, we're really trying to prove the midsegment theorem. So the first part of the midsegment theorem, if I look back up, is DE is parallel to OC. So in step 2, we're going to prove that DE is parallel to OC. Now, in order to do that, if I'm proving parallel means they have the same slope. Okay, so essentially here what we're going to be doing is we're going to be finding the slope of the line. Now remember, slope is the change in y over the change in x. So the first one I'm going to start with is I'm going to start with the slope of DE. So I have to do the change in y over the change in x. So I have my 2 points up here. Here's D, here's E, and I'm going to do the change in y. So I have an r and I have an r. So r minus r over the change in x, which is q plus p minus q. So q plus p minus q equals r minus r is 0. Q plus p minus q is p, but if we take 0 divided by p, our slope is 0. Okay, which if you're looking at this, this is a horizontal line, and a horizontal line has a slope of 0. Now we need to find the slope of OC. And I should have done that. Okay, slope of OC, change in y's. We've got 0, 0, and we've got 2p, 0. So my y's are 0 and 0. So 0 minus 0 over 2p minus 0 is 0 over 2p, which again is 0. So if we take a look at those, they have the same slope. So they are parallel. We just proved that they are parallel because they have the same slope. That's the first part of the midsegment theorem. And we did it. So far, so good. But step 3, we still have to prove that DE is half the length of OC. So we're going to go to step 3. And we're going to prove that, DE is 1/2 of OC. Now, in order to do that, we're going to have to find the distance. Now, the good thing about finding the distance here is we actually don't need the distance formula because these are horizontal lines. Okay, so if these are horizontal lines and I start with, let's say, DE, they're both up here at R. So really, I just have to figure out the distance between here and here, which is Q plus P and Q. So really, if I want the distance between these two things, we just have to subtract. So we're going to take Q plus P and we're going to subtract Q. So the length of DE is Q plus P minus Q. Okay, technically speaking, if we're doing a distance, it always has to be a positive number. So we could do absolute value here. And then Q minus Q is just going to give us P, which is a positive P. So the length of DE is P. Now we also have to find the length of OC. So now we're going to go back up and look for OC. And again, the nice thing is that this is a horizontal line. So I just need to know, well, this is 0 and this is 2p. So what's the distance between 0 and 2p? Well, that's 2p. So 2p minus 0. Again, it's a distance, so absolute value, but that's 2p. And then what do you notice about the distance between p and 2p? You just have to double it. So from p to 2p, you double it, which means DE is 1/2 of OC. So that's our proof. You have proved that the midsegment is parallel to the third side, and you have also proved that it is half the distance.